Third-party content has been copied and communicated pursuant to Part 5A or 5B of the Copyright Act, unless indicated otherwise.
Anyway guys, my name is Nick O'Brien. I'm a business development for the Asia Pacific division of Sefaira. Very honoured to be asked to come down and present today. I'm a Deakin grad myself, Deakin Burwood. I'm not sure if there's any rivalry still from those days, but I did study over there. So thanks a lot for inviting us to come down, Matt and Charmaine. Bit of a change in pace for our discussion today. I'm going to talk to you about Sefaira. Has anybody ever heard of Sefaira? Some blank faces. Okay. Well, Sefaira, basically, we're going to discuss a sustainability analysis tool, which we're talking about sustainability in concept stage. Now, I understand we've got a bit of a range of disciplines and backgrounds amongst us here. Architects, I think there's a QS before, some council members, construction management, that's right. So basically, my background, I'm a sustainable design consultant, that's where I come from. So I might be a little bit out of my depth here talking about BIM, but from my experience dealing with architects on a continual basis, most firms are moving towards some sort of BIM technology, be it Revit, ArchiCAD, etc. I know you're working with microstations a lot over here at the moment, but a couple of questions just to start with. I like to keep my presentations quite informal, so please speak up. What kind of tools do you use, the architects of the room, in early concept stage when you're creating designs? Bit of SketchUp, any hands for SketchUp? A little bit, yeah? Bit of Revit, concept design? Okay, cool. A whole lot of people that aren't architects as well, I'm guessing, is that right? Yeah, there's a few, okay, that's okay. So basically our tool is a cloud-based analytical tool that gives you immediate feedback on your concepts as you're creating them. Now we talk about sustainability, it's a word that gets tossed around a whole lot. Basically we're going to talk to you about efficiency. Sustainability is kind of getting a little confused, we think, moving to this new generation of technology with BIM, etc. We want to harness technologies that can inform early concept designers so that they can move forward, I guess, pick the low-hanging fruit in an early building's design to move towards true efficiency rather than sustainability. So this is what Sefaira is. Founded in 2009 over in London and New York. This is a clean tech company, raised a bunch of venture capitalist dollars to put together this tool. Luckily enough, we've got Josh Cates, which is one of the directors of engineering and customer success from the London team, has come over and joined me here in Melbourne, and we are now heading up the Asia Pacific division. You can see a whole lot of bigger firms around the world. You might recognise a couple of names up there. As you can see, we've got a whole lot of users that are using the tool around the world, and in Australia, we're slowly picking up that trend now. The tool's being used to teach architecture over at University of Melbourne. With any luck, if you guys want to talk to your lecturers, that'd be great. We might be able to come on and show it to you and use it in here as well. What we're going to do here for the discussion is show you a little bit about what Sefaira is, where it's come from, the tool, how it kind of fits in the BIM approach. And eventually I'm going to pass it over to Josh as well, who's with us, who'll take us through a demonstration using the tool. But if you do have any questions as I'm going through, please do pipe up and let me know. So there's the agenda, talking about it. I've already explained what we're going to do. So the trends and drivers that have sort of led to the creation of this technology, Sefaira. We're seeing, I guess, the integrated project delivery approach, which is obviously quite topical with the discussion today being BIM technology. And because it's a cloud-based tool that we're using, it's actually quite well integrated in that method. The rise of the cloud computing, obviously with BIM, the BIM approach. Our tool is cloud-based, so you just access it via the internet, a web browser. And of course, the growing initiative of efficient green building. You know, a building that's getting designed these days that's going to require a whole lot of energy consumption in the future is going to be obsolete. So we're going to move towards this new generation whereby efficiency is paramount. And when you can actually look at efficiency is really going to dictate just how efficient the building can be. I tend to think that it's an exciting time right now where all these technologies are coming out. Obviously, BIM is being taken up to a large degree, and you know it's really important at these early stages to be across all these different technologies, particularly when you hit industry, because a lot of firms, in fact, are moving towards BIM, and they are looking to the next generation, new architects that are coming out, to lead and champion that movement, going across from paper and pen over to new technologies like BIM and hopefully Sefaira. This is a curve that we call, it's the McLeany curve. Some people might recognise this curve, some might not. Basically, this is a curve that's talking about where sustainability analysis gets completed in the current design approach. So if you're looking across from left to right, to early concept stage across to design, detailed design, you see with curve one, as the curve one moves across from concept through to detail, the actual capacity to impact cost and the actual functional capabilities of your designs, it decreases, obviously, as you're increasing the detail of your design. The ability to make change actually decreases as we move along. But the cost that's associated from early concept across to detail with making any changes, that's growing exponentially, as you can see with curve two. Now what we're seeing with curve three there is where analysis is currently being completed, which is where we start to look at how this building is going to perform in terms of energy, water, carbon, etc. It's getting completed when a lot of decisions have been made. So we're almost halfway along the process by this curve. It gets expensive. The actual capacity to make changes reduces because you've made these decisions. And what we're trying to do with this data-driven approach using a tool like Sefaira is to move that curve towards the start of the process with curve 4, where it doesn't quite cost as much, and you can actually really impact the change. And what we see when we use that other approach of looking at design down the track is that you're bolting on strategies. You know, it's because you're using technologies that are engineer heavy. They're focused towards people that aren't in the design environment, and they require a whole lot of training expertise. They're quite slow, and they require a level of knowledge of passive design that is sort of, not passive design, a level of knowledge of analysis that's not really the designer's forte in the early stage. And they also require a whole lot of inputs that you don't have at early stage, which is, you know, building material types, you know, profiles of your occupants, etc. And it's hard to run any sort of accurate analysis when you don't have that information. And what we find is that that analysis gets completed at late stage, and it gets used as a form of validation. So you're validating designs rather than actually informing them, rather than using that information to impact an efficient building. Limits your options, and you see that bolt-on approach where you start bolting on, for example, over-specified glazing or over-the-top shading elements, because the real true organic options weren't taken up at the early stage. So we find that with our software, you're able to get an understanding of the credentials of your designs at early stage without doing too much work, really. We can look at energy, we can look at costs, we can look at water, the carbon intensity, the actual emissions that will be associated with the building running, and renewables. And we'll also be able to look at glare, so sunlight, daylight, and glare at a really early stage. So basically the proposition of using a technology like Sefaira is better quality design. Increasing market of yourself, I guess. This isn't a presentation normally aimed towards commercial clients, but it's also an increasing market for designers just as yourselves. Saves time and money, and we talked before, in fact, I think Charmaine and John both talked about removing the conflict and I guess integrating the method, or integrating the discussion between different project team members, right? What we can do is with a tool like Sefaira, because it's an integrated project tool, is we can have this conversation about efficiencies really early, and in fact involve your engineers with your architects, with your client, to find out what the implication is of each different design choice and where exactly we can streamline that process, which of course mitigates the risk of not delivering on your client's requirements as well. This is a bit of a slide talking about the technology itself. I won't go into this in too much detail, but basically this is a cloud-based tool. So in terms of its speed, we get results back using the cloud. We're harnessing hundreds of cloud servers to get results back for you in 10 seconds. That's what we aim for. Now, your consultants, you know, your sustainable design consultants like me, we used to run analysis on your buildings. In fact, we do run analysis on your buildings at that late stage, and that takes 12, 15, 18 hours to run some of the softwares that we use. And we're talking about 10 seconds. Opens up a whole new paradigm of analysis. You know, we can compare things like orientation, run 10 different models side by side to find the perfect sweet spot. We can use that kind of analysis for a range of different passive design ideas. Am I drawing blanks? Are people understanding where I'm going? Am I going too fast? Some nods. Okay, good. It's robust. The technology that we're using is quite a well-recognised technology. It's ASHRAE Radiant Time Series. It runs an hour-by-hour thermodynamic analysis of your building in its location. Using the cloud, pulls the local weather file. So it applies that to your site. It's all in the cloud, so Mac or PC independent, and it's scalable and accurate when compared against the tools that we were using as consultants, within plus or minus 10%, which is really great. Also introduces the Energy Plus engine. Some people might recognise the Energy Plus. This runs a thermal comfort analysis of your site as well, giving you an idea of what kind of temperatures are experienced in the space. This is the last slide I'm going to show you, just showing you where Sefaira sits in the realm of the different technologies that are available. Along the different BIM processes, you might recognise some of these technologies. You can see things like Ecotect or Energy Plus, TAS, etc. So we see that Sefaira is kind of aiming to be used at this really early concept stage, and it's reflected in its accessibility. It's focused towards architects. It's actually been built from the ground up for architects. I'm going to pass it over now to Josh. Josh is going to take us through the demo, so I'll just get across here. Got to use the map.
Thank you. So I think I saw some, thanks for that, Nick. I think I saw some hands for SketchUp, and I obviously know we're in a BIM event. So we do, at Sefaira, we actually develop everything in SketchUp first because it's a bit more flexible for a lot of things. But everything we do, we take it into Revit. So, but I want to show a little bit of both because we're developing some interesting things in SketchUp that within the next 6 months are all going to end up in Revit. But the majority of the presentation will be completely Revit based. So it's not going to be too SketchUp heavy for those of you that came here specifically to see sort of the traditional, BIM kind of tools. So what we want to do for analysis, I guess for the students, you don't realize how much engineers like myself and architects, they don't always get along the best in projects. And so this presentation Nick went through, when architects say that, it actually resonates really powerfully with them. Where they're like, yeah, because Sefaira is kind of building a bridge between the architects and the engineers in terms of this analysis that gets done. So, but what we found is we built this whole web-based platform that I'm going to show that you can analyze your designs so you know how they work in terms of is it too hot, cold, how do I make it better? And what we found with our customers is that they, which are mainly designers, they like spending time in their design environment, whether it's SketchUp or Revit, and they don't really want to go to another thing necessarily. So we built something called real-time analysis, and how that works is basically you just start drawing. Whoa, this is going to be, I'm on this little ramp here. I'm going to just try and draw something that is not going to be too architectural because I'm an engineer. So I'm going to draw a rectangular box with some flaws. Let me erase some stuff. And I'm going to just put in some windows as well. Now, as I'm drawing this, because SketchUp is completely free reign, we've got to have some way of interpreting things. So if I put on some glass, what Sefaira is doing just as I'm drawing is actually interpreting everything. So we're connected to the cloud here via my internet connection. When I hit refresh entities, it sends this whole model off to Sefaira's servers in the cloud, and it will come back and show us what Sefaira thinks all of these things are. So it's like, oh, it thinks this is a wall, it thinks this is glass, it thinks this is a roof. Show me all of the flaws. Okay, here they are, that's great. But at the same time, what it's doing, as I've just drawn this, is it's analyzing my massing immediately. So if I just come over to this screen, how does that look? It's a little bit off the screen. But you can see we can put this down as it's at New York at the moment. Let me just say Melbourne 3000. Set that location. It'll take the closest weather file here to Melbourne. Calculates my floor area. But it's also doing some interesting things. It's calculating my total energy use straight away, and it breaks down that total energy use between cooling, heating, lighting and appliances straight away. So I can see how my building is actually working with the energy flows. It's also calculating daylight, which in this case is excellent because it's a very narrow building with lots of glass. And it's also, we tried to gamify it a little bit and give you some benchmarks here. So here's 50% below what we call CBEX, and here's this 2030 challenge target for architects. So right now we're in the middle, so it's amber colored. If we get below this, it will be green. If it's above, it will be red. So you know how your building is performing. If we want to see how this cooling actually breaks down further, we've got this whole map here that we can look at, where we can see in this particular design, you know, anything that's in red here is bad for your building and anything in green is good. So we can go, okay, most of the bad stuff is coming from my west solar gain or my east solar gain. So you could click on that and actually go ahead and change your glass directly, or you could just make some design change like rotating your building around. And as soon as you make any change, it instantly just starts reanalyzing your design. And this is doing an hour-by-hour analysis of this design in this climate as an office. And it will, hopefully just in a few seconds, if we're going to live out the promise you just gave, Nick, of 10 seconds, it's going to come back for you. So here it is. We've got some, now it's majority north solar gain and a little bit of south. So what's interesting about this, I know in architecture school you learn about, well, you know, north solar gain is more impactful than south, but it's like, how much? How much more impactful is it? Like, is it twice as big? Is it 3 times as big? What happens if there are some surrounding buildings and it's not just perfectly north-south? So with this real-time analysis, you can start looking at more interesting things like around aspect ratio. You can start looking at improving the glazing ratio, putting shading on the design, all sorts of things. And in real time, it just reanalyzes everything for you and provides you the feedback. So we think this is a really interesting kind of new way for architects just to understand their designs without really having to do anything except design, which is what architects are doing most of their day. So that's that side, and all of this, as I say, is going to come into Revit over the next couple of months. But I'm going to pop into Revit and show that side of it as well. So this is what Revit looked like, and the models tend to be much more complicated because of what John was showing. You know, you've got all of these layers of information. You've got, if I open this up, you know, you can have lighting fixtures, you can have furniture systems, you can have all these detailed items. But all Sefaira does is we only take from your model what we need to analyze it. So we only take from it the glass, the walls, the floors, the roofs, and we leave everything else behind. So to get to Sefaira from your Revit model or SketchUp, you basically, we've got an ad in here, Sefaira, you click it, and it will open up a dialog where I can put my email and password in and sign in. So once I've signed in, there's exactly one button, which keeps it pretty simple, to upload to Sefaira. When I hit that, even for very complicated models like the ones you showed before, it takes about 10 seconds to actually upload just the bits we care about for the analysis. And straight away, it basically brings me back a URL. When I click that, I'm now just in a web browser. So everything else we're about to do today on that model is going to be in a web browser. And all of the information we get from that, we can go back into the model and keep on going with it. So this is a little bit stressful because I've got the internet on my little dongle here. It should be okay. So the first thing it's going to ask me to do is, what would I like to do with this model? Do I want to add it to an existing project or create a new one? I would add it to an existing project if I have a few different massing ideas, like maybe one with a courtyard, one without a courtyard, one tall and skinny, one short and fat, and I want to look at how they all perform relative to one another. Today I'm just going to look at this one. I will say Deacon. and I will put this, I'll just put it here because I know the postcode is this, and I'll map the address. This is just a Google map, so anything you can find it here. It just basically takes the closest weather file to this location and applies it to my project. Okay, so we've got a bit of a resolution issue here, but the next thing it's going to ask is what kind of building is this? So is it an office with, 750 people? What are the lights? What are the power loads? What are the diversity factors? You might not know any of that. So we've just got some standard defaults that you can select. Say here, this is an office. Or, this is a residential and it has a really different kind of profile. Or it's an office, but actually there's university students working really late. So you can just change it. You can change the lighting from typical office to good practice. You can change around the plug loads, whatever it is. For master plans, or multi-use schemes, you can add other space uses, so it can become quite complicated. But I'm just going to leave it as an office in Melbourne with my Revit geometry. And with those 3 bits of information, we can basically start analysing this design and figuring out how we can make it better. So this is just loading up the main project page now, where you can see I'm here, here's my weather file in Melbourne, I've got a resource mix, a space use, a tariff that I could come in and edit. I'm just going to leave all of that as is and just dive straight into the baseline concept here, which is where all of the analysis happens. So one interesting thing that I just missed out there is that you can actually manage your team in Sefaira, and that's what a lot of our customers do. So they will actually, the architect will start off but invite their engineer in, because normally energy modelling is the engineer's domain. And so we're kind of giving the power to architects to actually do it themselves, but they want to collaborate. So that's where the bridge comes in, and you can actually collaboratively do this together with the engineer. But all I have to do is hit the run analysis, and this is actually kicking off the same hour-by-hour analysis as we saw in SketchUp. Everything is the same, but it presents the information really differently, and you can optimize it a little bit differently as well. So while that's just running, just to give you a bit of a lay of the land here, we've got these 4 dimensions here on the left. We've got renewables, water, envelope, and HVAC that you can optimize separately. Things in envelope, we can look at optimizing the building orientation. We can look at things like optimizing the thermal mass of the building. So do you want exposed concrete or do you want a timber frame structure? What about the insulation in the walls, windows, and roofs? We can override facade glazing ratios and figure out, well, what is the optimal glazing ratio on my north facade? We could look at what the best shading scheme is. But we can see here, we've got some results back here now. So this office in Melbourne is consuming about 1.4 million kilowatt hours of energy per year. We're spending about $300,000 per year on this office in utility costs. We can see that the cooling is about $560,000 and the heating is $100,000. So even if you don't know what that exactly means, we can see here that we're massively cooling dominated. We can also add other results that we might be interested in. So we can say, well, I also care about carbon production. And it will instantly add here, we're using 750,000 kilograms of CO2. If I want to look at these numbers in a bit more detail, I can come down to the bottom of the screen where we've got a carousel of charts. So I can open up something like this, which is the monthly consumption, where we can see from January to December how this particular office is using energy between appliances, lighting, fans, cooling, hot water, and space heating. So you can see more visually, okay, we've got a bit of a cooling problem here. How are we going to fix that? Well, we can have a look at many things. We can look at conduction, we can look at renewables, we can look at water. But we might look at something like this, which is just the monthly heat gain. So it's like, how are we gaining heat in this building? Where's the cooling coming from? Well, the vast majority of cooling in this particular case is coming through solar loads. So we know just the sun coming through the window is the worst thing in this building. It's dominating the cooling load. So to fix that, we could look at things like performance glazing, or we could look at design alterations like putting shading on my design or reducing the glazing ratio, or some combination of those three things. So to do that in Sefaira, all I have to do is hit this new strategy button here at the top. So if I wanted to say, look at, maybe I've got light thermal mass, and I want to look at, well, how impactful would heavy thermal mass be? I can just hit this new strategy button, and I can say, well, let's look at some heavy thermal mass. And then I can just come here and click on this little light, this checkbox, and it will fly over into my strategy, and I can save it. And I can expand that and change it from light to heavy and save it. So now I'm going to be able to see what impact heavy thermal mass has against my baseline, which is light. I could have a new strategy that might be, let's look at having my glazing ratio on the north at 40%. So I can come here and grab the north facade glazing ratio, save that, and I will change that to 40%. So in my design it's more like about 60%, and I'm going to just reduce that a bit and see how that controls the solar load. I might also have a new strategy that is external shading, and just grab this brise-soleil structure and save that, and I'll just leave it as the default here, separation of 0.2 meters with a depth of 0.5. Now the nice thing about having cloud computing is when I run this analysis, it actually kicks off all of these simulations in parallel in the cloud. So you can look at multiple design options at the same time. So what you can see here is heavy thermal mass is actually reducing my energy consumption by 9%, my utility cost is coming down 8%, my cooling is coming down 18%, and my heating by 26%. So you might know that heavy thermal mass is a good idea, but how good is it? Well, that is how good it is, in this particular office building. If I have glazing ratios, if I reduce it to 40% on the north, my cooling comes down 30%, my costs are coming down 6%. External shading is actually reducing my cost by 19%, my cooling is going down 46%, and my heating is actually going up 47%. Because there's a balance to be had, because you put shading on and it shades your building in summer, it shades it in winter as well. So what's the ideal length of my shading device, So if we want to actually figure out what the optimal length of a shading device is, or what is the optimal building orientation, what's the best amount of insulation I should have, what's the best glazing ratio, the cloud is really good at that because we can kick off sort of parametric analysis. So if I want to look at what the optimal depth of shading is, I can turn on this brise-soleil, and next to the depth here is a little button to generate a response curve. So I could click that and say, all right, between 0 and say 0.6 meters, run 10 different simulations of my building with 10 different shading depths between 0 and 0.6 and graph it against energy. Run. So now I'm running, and I've done it on all facades at once, but I could get a bit finer about it. But it's now running 10 different buildings with 10 different shading lengths, and it's going to graph it against energy for me. So I'll be able to see if there's an inflection point, if there's a diminishing benefit from having more shading. And we get this back in real time. So this is now back, and what we can see here is that actually there is a huge benefit in putting shading on the design, but then at a certain point, at about 0.2 meters, it doesn't really get much better than that, and it massively flattens out after that. So any more shading on this particular design after that, yeah, it makes a bit of benefit, but it just costs a fortune. It doesn't really do much for me. And that's because, you know, if I look instead of at energy, if I have a look at heating and cooling, you can see that the cooling is going down and down and down, the heating is going up and up. And you know, where is the kind of best point between those two? So with this kind of information, I can actually come back out and I could change my external shading from 0.5 to 0.2, and I know that that's now an optimal value. I can run it and see how that's all working. Now, of course, Sefaira, or maybe not of course, some people think it does, but it doesn't. We don't change your model for you. We don't know how to make that look good. We just know what it does to the design. But it's good information to have, because now you could go back into your model and actually model it with the ideal shading in a way that looks appropriate for the building. So the next kind of thing is, well, what happens if you want to combine these things together? How, you know, you can't actually add up the benefits between individual strategies, because some things, when you put them together, they work really well. Like if you expose concrete in your design and you have natural ventilation, that works really well. But some things, other things cannibalize each other. So in Sefaira, to put things together, we have something called bundles, and I could just drag and drop different strategies together. So I can drag and drop all three of these together and call it my passive bundle and save it. And all that will happen is it just creates a new line item with this bundle of three strategies underneath it. Again, I can hit run analysis. It's now running the combined impact of those three strategies together. So it will be with external shading, with the north at 40%, and with heavy thermal mass, and it will give me the combined impact of that. So you can see, you know, it's 22% reduction in cost, 50% reduction in cooling, 9% increase in heating now. So if I want to keep on going with this passive bundle, I can actually create a concept, a new concept from the bundle. And maybe I want to start looking at the other stuff like renewables, sizing a rainwater tank, other more sophisticated HVAC stuff. I won't go into that today, but you can go into it. But what I can do is create the bundle, and you can see here a new concept is created. And I won't click here now. I will just come back out just to show you what I've done. So back in the main project page, we can see here that my baseline concept is here, and this is what we've just created, my passive bundle from the baseline concept. So now they're two separate concepts. I can also do something pretty interesting, which is add new massings. So this is the way you would do it for a SketchUp file. You do it slightly differently for the SketchUp and Revit. But I could come along and just add a different kind of massing. So maybe I also want to add to my project a kind of different sort of form of the building and see how the two forms actually compare against one another. Because I don't know if you realize how much impact just what it looks like can influence the energy and how people feel in that building by, you know, 30%, even more sometimes. So, you know, you put something on the paper and it just has huge, huge flow-on effects. So if you want to look at how that would impact, I'll just upload this building as well, which is a different kind of design. I'll let that load in for me. So you can see I've also drawn some surrounding buildings here as well, and I'll use this selected massing. And it will just load into the project.
Just while it's loading, does it take into consideration of surrounding buildings and shading and stuff?
Yeah, so all the surrounding buildings that you draw are taken in hour by hour as for all the shading. Yeah, we've got clients that will draw like really perfect trees, and it takes it into account. So, or you can do the engineering approach and just draw a block, but however you wish. So we can see now that we've got these two massings. This one I can see is 2,700 meters squared. This one's 10,000. So this is going to be a bit interesting. But I can grab them all and actually compare them to one another. And it's going to ask me, what do I want to compare about these different massings and my optimized concept here. And I'm just going to pick some things that I think might be interesting, like energy, water, and CO2, maybe the peak cooling, utility bills, footprint, whatever it is, and I can view this comparison. And it's going to pull out a kind of side-by-side comparison of all of the different massings, and I can sort of just rearrange this to be... So I've got, there's my baseline, this is my passive bundle, and this is my other massing. And you can see, I've gone from 134 to 107 kilowatt hours per meter squared. This other building is way higher than the other two. We can see how we've reduced the energy, in this blue area. This is the cooling. So we've really dropped that down. This one's a smaller building, so it's not got much energy at all. But from a peak space cooling demand point of view, which is what the mechanical engineers tend to care about, and architects, because it governs the spatial requirement in your floor spaces, your ceiling spaces. We've gone from 1,300 kilowatts to about 1,000. And we've gone, from the client's point of view, from $30 a meter squared to $23 a meter squared in running cost. This other building is $37 a meter squared, so it's much more expensive. That is a really, really quick run through. I know I don't want to keep you here all night, but we're happy to answer any questions you might have about it as well.
Sorry, I've got a question. I'm probably asking this on behalf of the building controls engineer. Is this plugin sort of just for 3D models and not for 2D?
Yeah, it is just for 3D. So because of Charmaine's question, like if you want to know if there's a surrounding building that's over it, you really want to know how much it is, because that has a big impact, or can have a big impact. So it's really important to have like the 3D model actually done.
How much does the software cost?
Well, for students, it's sort of pretty cheap. But we don't sell it just to one student.
Hopefully you can have a chat with your lecturers, and we'll continue the chat afterwards, because we'd love to come and get it available to you, so we'll have a chat. It's not your worry just yet.
But yeah, that's a great compliment. This is really, I'm pretty passionate about this at Sefaira, because architects don't actually understand how their designs work. They understand how populations go around the buildings, but not many architects really know, like, this building will overheat in this section, and if we put the shade on, it will actually reduce it enough that it will be comfortable. That is not, they don't have the so-called rules of thumb, this and that, but they don't know, they've got no way to analyze it and no communication. So then engineers are actually quite expensive. They wait all this time, they go to the engineer says, oh, this is going to overheat, but the engineer's time is so expensive that they don't really look into it every single bit. Maybe Wooden Groove does.
One exception.
Yeah, one exception. And so having this information, like, designers care a lot about their designs, and understanding how it works is really, I think, very important. That's my little 2 cents here.
It's a very interesting issue. I actually have 3 questions.
Okay.
The first one is that you basically compare the energy consumption of the energy efficiency for different kind of design. But did you
you consider the cost benefit if you change the design options?
I did an amazing thing there and just cancelled the screen. Excellent. Okay. All right. So the answer is everything in our application is exportable. So you can actually, hold on. So I did a few options, like reducing my north glazing ratio. That would actually saves money in running cost, but it also saves a lot of money in build cost. Or optimizing the length of the shade also would save money in build cost and running cost. But we don't have it inbuilt to this tool because of what Matt had talked about with, it's quite difficult. But you can export everything to Excel and give it to your QS for them to be able to, and then manipulate it however. So.
That's good. And the next question is about energy generation. It's basically regarding the PV system in buildings. If they say we're using PV system in buildings, it will generate energy instead of have energy consumption. So can we consider that in this software?
Yeah. So actually, what's really nice about having renewables in the same program here on this other tab is that we're doing hour-by-hour analysis of your building and figuring out how much it consumes every hour. And we're also doing hour-by-hour analysis of how much your renewables are generating. So we know how much goes into your building and how much gets exported. So if I come into renewables, you can add different kinds of renewables like facade or roof integrated PV, which takes into account surrounding buildings, CHP, wind turbines, solar thermal hot water, ground source heat pumps. You just can turn these on. I could run a response curve on this and say from 0 to 10,000 meters, run 10 different simulations, graph it against energy, and I can see in real time how different amounts of PV on my roof or whatever will actually impact my energy consumption. And with this kind of tool, you can actually make net zero energy buildings because you can say, how much can I produce? How much does my building consume? And try and actually get it leveled out. So you can say, like, it's starting to flatten out here around sort of 6,000, but, you wouldn't necessarily want any more than... So you can kind of, reduce the energy, increase the generation.
Excellent. The last question is about life cycle energy analysis. So basically in your software now, it's for the occupancy that stage regarding energy generation or energy consumption. But how about the whole life cycle of the building?
We don't do that yet. So you could export this, because you've currently got your energy. But of course, you could export it in Excel and do all kinds of interesting modeling around utility cost rises, carbon decreases in the grid, and see how different scenarios. A lot of our customers do that, but you can't. It's not baked in.
It's interesting though that you do raise that point though, because there are a number of aspects of the tool that are continually being developed, and so life cycle assessment is something that's been raised by a few different people, and our users, when they continually feed back like that to us, it's quite a flexible tool, and the roadmap of where it's heading is such that we can be adding things on like that. And I would think that that's something that might be looked into in the future for the tool, because it's something that would be very valuable. We agree.
And certainly with the cloud approach, I think a lot of the tools are looking at integrating and almost being like a dashboard. So you could, if you had enough connections through to utility suppliers and those sort of things, that could feed back and do planned versus actual and ongoing costs. There'd be a caveat to say that you're warranting it to a certain point. It would come back to the engineers, of course, like John in the room. But it'd be fantastic to collect that information along the way.
Go for it.
Just want to ask, this simulation engine is energy plus, is
We've actually got two. So we use Energy Plus for some of our calculations with our interface, but I didn't show them. They're the thermal comfort side. So if you have natural ventilation, instead of looking at energy, you're looking at like how uncomfortable it would be in the space. So if you're doing like a residential thing, and then we use Energy Plus. Most of all the calculations I showed today were actually using a different kind of engine that's based on the ASHRAE Radiant Time Series is what it's called. It's a well-established energy modeling methodology that we use, but depending on which calculation you do, you hit different things, engines. And for the daylighting, we use Radiance and DaySim.
Another thing is the source for the weather file.
Yes.
Is it from?
We've taken a few from different places around the world. So we got the majority from the Department of Energy in the US. We will upload ones that our customers want as well, if they want them. But we've got about 3,000 weather files at the moment uploaded. If there's, like in England, they use specialist regulation ones. We've got those ones. It's different ones, but we use ones in Australia that are used for regulation calculations. So.
Just two last things.
Okay.
The first one is, does it work with any geometry, like whatever, like curves or
yeah.
calculation, like it's accurate?
We do have a limit, at least in SketchUp, of you can have 3,000 faces, which is very pretty like we've modeled some Zaha Hadid stuff, and it actually has worked, which is pretty incredible. But if it's 3,000 faces, but you can have it in any geometric way you want. But that's our limit at the moment. But we haven't tried to raise it because no one really hits it. So it used to be much lower, now it's that. Did you have one more?
Yeah, that's the last.
Yeah.
For the simulation you have just run, do you define like a temperature before you calculate the energy? You say energy for cooling or heating, and so you define like what temperature you need inside the space first. So
of course, yeah. So I actually had some heating and cooling set points, but it came through as a default as like to 22 degrees or something, and that's it.
Different like HVAC system that could change the.
Yeah, I mean obviously the wider you make the bands, the less energy it will use. So if I say, well, I only want to cool it down to 27 degrees, then you'll be like, oh yeah, well, you're only cooling a little bit. So that's it.
I was just wondering, at the moment, we showed us the program as a plugin in web browser. Is it possible to import models that aren't Revit-based or aren't SketchUp-based, so you have that sort of diversity from programs, or are you predominantly just in those?
Yeah. So the reason we went with SketchUp is initially, at least, is because it's sort of like the conduit for a lot of other programs. So I know that you use Bentley in Deakin, and we've got, customers that use that. We've kind of got ways, because most things you can get into SketchUp very easily, like through 3ds or DXF or whatever. ArchiCAD exports as SketchUp as a native export. So usually it takes, 10 minutes, and then you do everything in the cloud, and then you go straight back to your MicroStation model, for example. So we don't ask our clients to do 2 models in parallel, like a SketchUp model and their model. We just ask them to use their model, take a snapshot, go through SketchUp and into the cloud, do all the analysis, and go straight back to their existing model.
I don't know much about SketchUp. I don't know how good it is in the detailed models.
Yep.
So if you have when you generate curves and things like that, is that, I know it's much better in Revit, but if you brought it from the external program in SketchUp,
Yep.
does SketchUp handle that sort of detailing?
I don't know what you mean by exactly by the detailing, but yes, I'm going to just say yes. But maybe You can ask me more at the BIM drinks. But yes, it can.
There is I guess, a little bit misnomer in that the energy analysis you need at the early stage doesn't need the resolution of the curves and those shapes as much as you think it does. Caveat there is that there's a building in LA at the Las Vegas at the moment, and the one in London you might have heard about, which is reflecting light back onto a car. And yeah, you don't really want to do that either. So that curve is pretty important, I guess, to figure out. But yeah, the complexities of the shapes that generally the Sahara and Guggenheim and stuff, they're not going to have a huge impact in some cases to the overall information you get back. Now, correct me if I'm wrong, but
no, you're exactly right.
So the architects especially get caught up in this idea of NURBS and all this stuff. It doesn't really matter for this pass.
So, yeah, is this
Who's
program just like a design guide, or is it?
Who's asking this question?
Yeah.
Okay. Ventriloquist.
Is this program aiming to be a compliance tool as well?
No. Maybe one day, but I'm actually pretty passionate about. Sorry, are we out of time?
This is the last one, and then if you've got more discussion, that's why we've got previous years afterwards, and we'll address it then. But if you want to finish up on this one, and we'll keep moving.
Okay, thanks. I don't want to override anyone. So it's a really interesting thing because a lot of architects will see this and be like, wow, this, you can't imagine the pain that architects go through with the engineers doing the regulation calcs. So they'll ask, wow, this looks great. Does it do the full regulation so I can basically get rid of my engineer? And the answer is no, and we've sort of done that kind of intentionally at this stage because most architects, not all, but most don't understand how their designs they don't even have this basic level of, okay, you've got heavy thermal mass. How much is that going to reduce your cooling? Like, to what magnitude? Is it going to reduce your heating as well? Or is it going to increase your heating? Or is it going to decrease it? They don't know. So just to have this is actually very useful. And then they can actually use this in collaboration with the engineer and go, okay, this is telling me that heavy thermal mass is having some good benefits. And then they work with the engineer to say, well, how much thermal mass do we actually need? And that's where the regulation tools, the much more detailed tools, are really great. And the engineer can work through much more detailed analysis that will eventually go on to be the regulation calculation.
It's a little bit like that a point about the QS. You won't get do without an extremely good environmental engineer. You'll get some ideas along the way, but this will then feed in. I think the idea of working in collaboration with the environmental engineers like Wood & Grieve or others, and they can be working through this interface, would be fantastic.
Thank you very much.
Thank you.